Hey guys, we're going to be talking about the difference between exponential functions, which is our new thing. This is an exponential function, and linear, what we're used to, right? Y equals mx plus b. So we're going to talk about all the differences between the two, and then that's your homework, is a couple sections that Delta Math has getting you to practice figuring out the difference. So let's talk about linear, what we know and love. Linear grows by adding. Okay. And the graph is a straight line. And it grows by the rate of change. That is a nice word for, or a nice phrase, for a slope. Exponential, our new thing, doesn't grow by adding anymore. It grows by multiplying, which makes it grow really, really fast. So instead of it being a nice, straight, consistent line, it goes really, really slow, and then it curves upwards really fast. Okay, and in context, it grows by a factor, percent, or a ratio. Ratio is another word for a fraction. You're going to hear the word ratio a lot. So as our functions, like when we're writing them as, equals, blah, 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 right? M is our slope, X is our input, B is our y-intercept. A is now our y-intercept. We'll be graphing these in 9.3, so that's where this will really come in. Don't worry about it too much right now. B is our growth or decay factor. Think of it as your slope, okay? It's what's going to tell us how much we're counting up by, like a slope does. And X, again, is our input. That's our whole thing about functions is you plug something in, you get something out. Okay? As a table, as your X values increase by 1, see, 0, 1, 2, 3, linear grows by adding. So 0 to 5, well, that means I added 5. And notice my pattern remains the same. If your pattern remains the same, you're good. Come over here. 1 plus 1 is 2. 2 plus 1 is not 4. So we're not growing by adding anymore. We're growing by multiplying. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Okay. And my graphs. Straight line, curves upwards. In context, flip your page for me. Every month, so let's say like January, February, March, 1 million people visit the Met Museum, in NYC. So January I have 1 million people. In February that's another 1 million people. In March that's another 1 million people. Okay, if I was being asked how many people there were that went to the museum after 3 months. Sorry, I had to pause. So let me start over just really quick. If I'm asked how many people have gone to the Met Museum after 3 months, you would add up all the millions and you'd say 3 million. You wouldn't multiply up all the millions and have, trillions and kabillions of people. You just add them. Okay? But if I'm in if I'm in exponential and a number of bacteria in a petri dish double every day, well, if I start out with 5, double that, that's 10. Double that, that's 20. See, I'm growing by a lot more, and I'm growing by timesing it by 2. Okay? So that's how we're going to do this. This is the first section of our homework. It's multiple choice. Which of the contexts below could be modeled by a linear function? Remember, linear grows by adding, and it grows by a slope, not a ratio, fraction, percent, or a factor. Okay, so let's take a look. The amount of a certain medication in a person's bloodstream decreases by 3/4 every month. 3/4 is a fraction, aka a ratio. So I know that this is going to be exponential. I'm just going to write expo for short. I don't even have to read that, but let's do it. Car depreciates at a rate of 3.5% per year. That is a percent. What grows by a percent? Exponential. The music service has a fixed monthly cost and charges 45 cents for each downloaded song. Well, if I download one song, that's 45 cents. If I download two, am I multiplying 45 cents or am I going to add 45 cents more? That's kind of what you're asking yourself. The answer is you would add them. So you say like 45 plus 45, that's 2 songs, plus another 45 cents. Okay, so this would be my linear. Let's really quick just talk about the last one. I don't even have to look. It says percent. That's exponential. Let's try it one more time. Which could not be modeled by an exponential function. Okay, not exponential is the same as linear. Please make sure you know what it's asking you. Okay, an elevator descends at a rate of 9 feet per second. Okay, well, 1 second is 9 feet. 2 seconds is 9 plus 9 feet. Oh. So I'm adding, okay, I would say 18, right? 18 feet. 1 more second would be 27 feet. I'm adding 9 each time, okay? So this is going to be my linear. I see really quickly these are percents, so I know those are exponential. And my last one, a population of 250 bacteria quadruples every month. Quadruples means times by 4. Okay, doubles means times by 2. Triples means times by 3. Okay, so anytime you see a word like that, it is going to be exponential. That's a factor. Okay, this is what we mean when we say factor. Last section of your homework. I just want to go through these little, like, really quick. I'll go through how to know how for sure how to do them. Okay. When it is linear, remember it grows by adding. So if I want to find what it's adding by, we do have a little formula for it. And it's going to be like the second term or minus the first term. Okay? So if I want to test if this is linear, I would say negative 320 minus negative 256. You might be thinking to yourself, well, I can just see it's subtracting by 64. And you'd be right. I plug it into this formula, I get negative 64. But I'm testing, is it linear? If it is linear, the pattern will remain the same. I will be subtracting 4 the whole time. But I do this, I've got negative 400 minus negative 320. You might be able to just see it, and that's great. That is subtracting 80. My linear pattern is not the same. So I know that it is not linear. Here's how I prove what the ratio is for if it's exponential. Remember, it's multiplying now, not adding or subtracting. So if I'm multiplying, if I want to figure out what it's multiplying by, instead of second minus the first, I would do second divided by the first. So let's try it. Let's do negative 320 divided by negative 256. If you plug that in your calculator, you get 1.25. Okay, good, but it has to work at least more than once. So let's try it again. I'm going to do the second minus the first again, but I'm going to do it with these two. Negative 400 divided by negative 320. That is also 1.25. And if I did it with 500 negative 500 divided by negative 400, I would again get 1.25. So that's how I prove if it's exponential versus linear. is these two little formulas here. Here's what I put in the drop-down menus. This function is exponential because, I can't remember what it says, but it says ratios. Something about the ratios all being the same, because your ratios are these 1.25s, and they're all the same. Okay, let's check again. Think to yourself, what do you think this is going to be? Okay, let's try it out. Linear. I'm going to try linear first. -10, because that's my second term, minus -16. That is going to be +6. And then I'll try it again. -4 minus -10, because that's second minus the first. That is also 6. So I'm adding 6 as I go on. And notice I never stop. I'm adding 6 the whole time. So I know that it's linear because your first differences are constant. Something like that. Sorry, I don't have my notes in front of me. Okay. The differences, that's your second minus first thing, right? Minusing is a difference. So that's what that's referencing, the differences. Ratios is referencing this formula. Okay. Try your homework out. Email me if you have any questions. Thank you so much. Have a good day.